When we have a lens, we change the medium through which light passes. As we saw with Snell's law, this means we get refraction, or bending of light. In this class, we use the thin lens approximation, meaning the material the lens is made of, which is typically glass, is so thin that we don't need to worry too much about what's going on inside the glass itself. Now, one of our type of lenses is a diverging lens. This type of lens is thicker at the edges and thinner in the middle. It causes light rays to diverge away from the focus and actually will almost always create a virtual image. Now let's look at this in a diagram. Here red is our object and blue will ultimately be the image we'll create. I need to define three principal rays to find my image that I'm creating. The parallel ray will come in parallel to the optical axis and diverge away from the near side focal length, so I can trace my line back to show that it actually goes through that focal length. The central ray, as with both types of lenses that we'll look at, just goes straight through the middle of the lens unperturbed. Now the focal ray is weird in a diverging lens. In this case, it's going to try to go through the focal length on the other side of the diverging lens and emerge parallel. So as we can see, these are all diverging away from each other and therefore can't converge. So where do they converge? Well, I trace them back and I see, hey, there's a virtual image created right there. Now you should be able to see how the diverging lens affects objects when these objects are placed within the focal length, at the focal length, and beyond. So try ray diagrams and the lens equation to figure out how these images will differ.